Good afternoon, everybody. My name is Mitch Robertson, and I'm back for another in the series of Why Wired Data. We're going to talk about one of the last pieces in my whole series about HTTP. Series is kind of based on this interview question that we came up with a long time ago about what happens when I type www.google.com in my browser from TCP stack perspective. We kind of walked through the process. I've already got stuff up on name resolution. I've got the TCP three-way handshake, TLS handshake, and I'm getting ready to do the HTTP, the request and the response. And then maybe we might talk about the TCP fin. And I'm going to do some more breakouts on each one of these and some more things of showing how it all works. But I wanted to get going with this and see how well, finish up this last in the series so I can get on to some of the other ones that are a little more interesting. Um, HTTP is a layer 7 protocol used by all browsers. There's not a browser out there that doesn't use it. And so it's something that I think everybody should know about. And so many things today are using HTTP. It's kind of the most common, besides DNS, protocol that's out there and in use. A lot of people will say, well, HTTPS is more in use than HTTP. Well, the fact of it is HTTP is just really the core meat protocol, because HTTPS is really the encapsulation piece. It's adding the SSL layer on top of it. HTTP is what's doing all the work. So it really is the most widely used protocol out there for most systems. And there's many things that are part of it, and I'm not going to go into all the details of it. Again, I'm trying to just get this as basic as possible and keep people thinking about what can I get out of it and what can I get out of that wired data. And why is that wired data so important? And why do I love looking at it and love using it? Because of the data and the information it gives me. So in an HTTP conversation, you have a request and a response. Most requests, there's different methods. There's the get, the head, the post, the put, the delete, the connect options, trace and patch. The ones I see most is get and post. But there's oftentimes others that might be put in there. But get and post are really commonly used today. And so oftentimes if I'm just getting a page, it's going to be a get. If I'm trying to post data or send data to that website, it'll be a post in most cases. With the response, there's all kinds of things that happen in the response. If I'm posting data at the end of the data post when it's complete, I might get a 200 OK saying I received all your data. If I'm just getting a page, when I go and get at that single page, the response returns a 200 OK. Along with that, all the information that's supposed to display in that page. So 200 OK is kind of important, and most people are used to seeing it. You'll see some stuff on 404s, page not found. So you see that on a lot of memes. Facebook, a lot of places that you go out, they've got all kinds of things that post and talk about 404s. So page not found. 413, payload too large. We might see that again in this presentation. Might not, I can't remember for sure. But the payload is too large. So whatever we sent up or requested to pull down was too large, wasn't accessible. And so there's just all kinds of little things. Most applications consider all the 500 server codes errors. And that's important to realize, that when we talk about errors, oftentimes from an HTTP perspective, we're talking about 500 codes, right? So these are not necessarily errors. They're legitimate pages or legitimate codes, but many systems do not treat those as errors. And notice this is, somebody will be able to tell where I copied this from. It's a long story, but there's some stuff tied to that. But I'm sure you'll see some of the this data elsewhere. So this is just status codes that can be returned, and you can do custom codes. So if I'm a programmer, I could actually set up a custom code that says I am a teapot. It could return an expectation field. It could return all kinds of things if I wanted to, and I can make custom codes and custom fields that give me more information. A lot of these are not even used, so just something to be aware of. So it's important to take a look at those response status codes and kind of figure out what your baseline is. Taking a look at this, you see you got 200s happening, and you also got 401s. In this case, you it looks like you have a pretty decent amount of 401s compared to your 200s. Obviously, there's more 200s than 401s. Um, but 401 is a challenge, an auth failure, which not most, but many websites or base IIS authentication does a challenge response. So it says, hey, you're a client and you're trying to connect to me. You try to connect me with anonymous. So it gets a 401 response back. And in that 401 response, the client is told what kind of authentication to use. So it's not uncommon to see 401s in some environments, but it's understanding your application that becomes really important. Interesting thing is this server also had some 500, so it had some internal server errors that potentially are affecting the end users. So when you see things like that, you definitely want to pay attention. And then here's your infamous 404, page isn't found. And I like to monitor those. It's sometimes normal, and maybe you have developers that have written code that are constantly referring to pages that aren't there anymore. I do push for our developers to clean that kind of thing up. And if I see it, I like to get it stopped. It is kind of a cool thing because when you have automated tools that are scanning tools, those kind of things, and they go out and try all these different URLs or different things to hit, they'll return a bunch of 404s and you might be able to find a bad guy by seeing that. But if this is all encrypted, you're never going to see any of this data. So remember, if this is encrypted, then you won't see this. It won't happen. So I won't get that data. That's not good. And so by having that, I can tell a lot of different things in the type of requests that people are sending up and a lot of other things. Notice on this one, you can see I have the 413 error code sitting there. And oh, see right there, 413. So we had a request an entity too large, common when moving large files. So what was happening is somebody was moving a large file and it was too large for IIS to accept it. This is a really good one to know about. Exchange might be a good idea to know about this one. If you do a lot of Exchange administration, might be a good idea to know about this. Here's where it really gets interesting to me. And I'm going to talk about server processing time, but before I do, you can see one of the cool things is if you have the right graphs and you're looking at packet data all the time. So notice I'm looking at this packet data from 3 o'clock in the afternoon to 1 o'clock the next day. You can see I have a big hit, a lot of responses. Be nice, I should really capture requests just to see if my requests match my number of responses. That would be cool, but that's something to think about. But you also have a bunch of errors at the same time. So now I know potentially during this time frame, I might have had a problem last night. In this case, I really would like to see if my requests were exactly the same as my responses, because if every request got an error, that's a good thing. If every request never got anything back, that's also a bad thing. So I really do like to see my requests first response, but that's a whole nother ballgame that we'll talk about later. Right now, what I want to show you is this. This was fascinating to me, and I think a lot of people don't think about it, and have never thought about the fact that I can get server response time. I can tell how well a server is performing by looking at data on the wire. And so you have a request transfer time. So how long does it take for me to send that request from the client to the server? You can get server processing time, and I want to try to explain how that works here in a little bit. How long did it take for the response time to transfer, right? And then the round trip time. And in order to really, for all of these to be correct, you have to know the round trip time. Round trip time becomes key to help measuring the others. Okay. And we're going to kind of talk about that a little bit. Here I've got my client that is sitting here and going to make a web request to a page through a firewall. They're going to hit some router somewhere as a part of this process, and they're going to go through a firewall and hit a server on the other side, right? And so they do the normal send, ACK, and ACK. And so you've got this time right here that is measured, and this is the beginning of measuring your round trip time, or your RTT. This tells you how well that network's responding. And so because if I get my SYNAC back really quick, let's say 25 milliseconds, then I know that connection to that server, I'm going through routers and whatever else that I might be going through, and I'm going through that and I'm getting a reply back pretty darn quick. Well, that's cool. But here I mentioned response times, right? A server response times, because really a server, the OS, the operating system, the application doesn't do a whole lot with that three-way handshake. What does do a whole lot with the application on the server, the IIS, the app pool, those kind of things, is the HTTP data that's going to it. So you have an HTTP request that travels across, and when it goes across, it hits the other side. So I start counting when I send that HTTPS request. And because my tap, or the data that I'm measuring with, is sitting right here, it starts looking at that data and going, okay, I'm counting from the time that request starts to the time I get an ACK back. That tells me how long that request took, because I see the request going across and I see the data going across with it, right? So if I'm sending a push, if I'm pushing data up, or I'm posting data up, I see that post command start, and then I see all the packets it takes to get that post completed, and I should see an acknowledgement coming back, and that tells me how long that took from here to here. And the interesting thing is I see when that HTTP request completes. So if it's 10 packets for the request, when I see it complete, then I start measuring again to get the time between the last packet goes through, and I start waiting for my ACK back. Well, when that last packet goes through and I see the ACK come back, if that ACK still comes back in my 25 millisecond time frame, I know my round trip time hasn't changed. My round trip time is good. So that difference between the start of that packet and the beginning or the end of that last packet and waiting for the acknowledgement, that's the time that it took for it to receive the request. So the application got the request and it told the TCP stack, I've got everything, and you're good to acknowledgement. So now the TCP stack sends that ACK back, and so now we know the application had a decent time. Maybe it was 10 milliseconds in accepting that request. So that request time is really important to know that application could handle the load that's being sent to it, the amount of data that's going to it, and it acknowledges it in fairly quick time. Well, then we sit and we wait from the time of the ACK, and we start counting again. And we're counting now between here and the first packet of the response and the last packet of the response. So now we see that first packet come in and the last packet, and that first and last packet often tell us the response time again, because did all those packets come pretty quick? Because we see that first one, we generally will see the last one fairly quick after it, especially fall under 25 milliseconds. But that time in between here and here now tells me it took that server that long to process it. That's part of the beauty of understanding the connections. And so even though my tap is sitting here, I'm telling you and giving a pretty good idea of how long it's taking for this server somewhere else to process that request. I can't even spell today. So that's important for me to be able to tell. And so it gives me a lot of information. Again, remember in the first slide, or the slide just before this, we had the data that we were getting. We had the transfer, we had the request, the response, and the server processing time. That's what all of this entails. And that's how we measure it, is by keeping track of when those packets hit and the acknowledgments that come back through it. So now I've got pretty good data of what my server response time is. And I can generally tell that the server outside of my organization may be responding slowly if I have that data decrypted. Actually can do it with encrypted data as well, because I've got to pay attention to the handshake. And some things in the SSL handshake can give you some indications of server performance on the other side as well. But it's not as good long term, because remember, I make a TCP connection and I make an SSL handshake. So if I have this three-way handshake that went up here, right, I could have 200 HTTP requests that happen inside this one TCP session. So my performance could change. The networking performance could change during that time period. So that's why it's important to be able to pay attention to the round trip. And when you pay attention to the round trip, some applications only measure this beginning send, ACK. But with RevealX, it continues to measure every time it sees the last packet of the request go up, the ACK come back, right? So now it's constantly getting the sampling rate of what the round trip time is during that whole conversation. So if that conversation goes on for 30 minutes, it's sampling that the whole time and continuing to update the RTT so we know what the round trip time was. And each individual HTTP request. So if I've got 200, I should see performance statistics for all 200 requests and responses coming back. So then it can average it out based on time and those kind of things and tell you how well that server was performing. Pretty slick stuff. And that's where it's really cool. The more you do this and the more you look at this wired data, the more data you start to figure out and go, wow, I can do a lot of cool stuff with this. So this is why I like wired data. I think wired data is extremely important to us. And I think the value of it is just beginning to be understood. Many organizations I've dealt with had wired data, and they had one or two people that understood the value of it. But because of some of the tools that are coming out, like RevealX, more and more companies are starting to understand the total value of it. You can use it as a security tool. You can use it as a performance management tool. You can use it for finding errors, finding development problems, server misconfigurations. You can use it for change control to see that some changes were actually effective. I talked about that earlier about some of the stuff that goes on with like WPAD or TLS. You're trying to remove versions of TLS and trying to see that it actually did what you thought it was going to do. This type of tool can tell you a lot of different things, and it's a matter of sitting down and spending time in it. So this is kind of wrapping up the end of my series on this. I'm going to get more in depth into some other testing and some other data that I get out of RevealX and start exposing that to people as we go. So I hope you'll take the time to subscribe to know when more videos are coming. I hope you enjoyed this. Please leave comments. I'd love to see them, and hopefully it provides you some value. Thanks again, and have a great evening.